On August 30th, 2025, Ukraine launched one of its boldest operations yet against Russian forces in Crimea. At dawn, 3 massive Flamingo cruise missiles, each carrying a 1,050-kilogram warhead, were unleashed alongside swarms of UJ-26 kamikaze drones. The drones blinded Russian radar and disrupted communications, paving the way for the Flamingos to strike at low altitude, slipping past S-400 defenses. Within minutes, the FSB command base at Armyansk was crippled, communications severed, and the Sevastopol pier left in ruins, with patrol boats damaged and fuel lines destroyed. This coordinated strike proved that even layered Russian air defenses can be breached with precision timing and tactical deception. Could this be the turning point that reshapes the balance in the Black Sea? Before we begin, don't forget to subscribe to the channel and hit the notification bell so you don't miss any other videos. August 30th, 2025 at exactly 07 in the morning, Ukraine launched a coordinated strike from the Odessa coastline. The opening move involved Flamingo cruise missiles, a new system weighing 7 tons each, with a combat radius of 3,000 kilometers and carrying a heavy warhead of 1,150 kilograms. Their trajectory was directed toward critical Russian positions in Crimea. For the first time, these missiles appeared in broad daylight during active hostilities, placed openly on launch ramps despite the constant presence of S-400 batteries guarding Crimean airspace. It was a calculated risk. Ukraine understood that the moment of preparation, when Russian generals were focused on offensive planning through Crimea, would create gaps in their defensive chain. This was the exact vulnerability Kyiv intended to exploit. The Flamingo missiles, though bulky and slow compared to supersonic cruise systems, were designed for tactical endurance. Their fiberglass composite airframes reduced susceptibility to Russian electronic warfare, while their low-altitude flight profile masked them beneath the radar horizon. When launched in sequence, they transitioned to terrain-following mode, cruising parallel to the coastline at subsonic speeds of roughly 950 kilometers per hour. Redundant guidance systems, altimeter, inertial navigation, and GNSS ensured resilience. In case of jamming, radar altimeter and digital terrain reference would maintain course integrity. The weapons were not simply tools of destruction. With their bunker-busting fuse and immense payload, each Flamingo had the potential to paralyze or collapse fortified installations with a single strike. Yet the missiles were only one part of the plan. Ukraine introduced another layer, UJ-26 long-range kamikaze drones. Each UAV carried a high explosive charge in the 25 to 30 kilogram class, significantly lighter than the Flamingos, but optimized for precision against radar and communications nodes. Their airframes, built from composite material, left only faint radar traces, 1 or 2 cells per scan on Russian tracking systems. Flying low and steady at 150 to 180 kilometers per hour, guided by GNSS and inertial backup, they possessed sufficient range 200 to 400 kilometers to reach designated terminals, even under jamming conditions. These drones were not meant to overwhelm by numbers alone, but to impose critical seconds of blindness in the Russian air defense network. The sequencing was deliberate. At 07, as Russian intelligence officers inside Armyansk reviewed attack plans against southern Ukrainian towns, the first wave of UJ-26 drones crossed into Crimean airspace. Their flight time was estimated at 45 to 50 minutes. Roughly half an hour later, 3 Flamingo missiles ignited in 5-second intervals. This meant that both weapons, drones, and missiles would converge on target areas within the same tactical window, creating a synchronized load on detection and interception systems. The drones approached first, entering from both the northwest and northeast vectors. The first blinding strike was aimed at the power distribution cabinet of a 96L6 AP detection radar. The explosion did not destroy the antenna, but it injected delay into the radar's power and signal chain, lengthening the classification cycle for operators. Soon after, another drone severed the waveguide of the MR-10M1 coastal surveillance radar. Its antenna continued rotating, but the signal path was gone. This was the essence of Ukraine's approach, not to dismantle the entire network, which would have been impossible, but to create critical lags measured in seconds that would prove decisive once the Flamingos arrived. Russian defenses responded. Pantsir units fired reflexively, downing 2 drones. 4 others, however, struck their cabins and power distribution nodes. These impacts created the illusion of a functioning radar grid, but with corrupted output, extending operator reaction time just enough for low-altitude missiles to slip through. Each second lost in classification or lock-on effectively narrowed the intercept window. By the time operators regained clarity, the Flamingos would already be approaching inside 20 kilometers beneath the radar horizon, leaving virtually no margin for frontal interception. The design was clear. Kamikaze UAVs would impose a fog of delay, and into that fog the Flamingos would glide, heavy warheads primed for decisive strikes. Ukraine had accepted enormous risk by staging such large missiles in open daylight under Russian surveillance, but the payoff was a synchronized strike that combined electronic, kinetic, and temporal pressure on the layered defense. The battlefield clock now ticked in milliseconds, and the gap between recognition and reaction would decide whether Crimea's fortified shield could withstand the storm. As the drone's explosions rippled across Crimea's detection grid, the Flamingo missiles entered their final approach. Each one had been programmed with overlapping guidance redundancies to counter Russia's known strength in electronic warfare. The key risk was GNSS jamming. But in addition to satellite navigation, the missiles relied on inertial systems, radar altimetry, and digital terrain mapping. Even brief interference would not derail their terminal accuracy. Flamingo 1's trajectory locked onto the FSB border security complex in Armyansk. Its designated target was the underground command and communications center, protected by reinforced concrete. The missile descended to an altitude of 20 to 25 meters, skimming terrain features to minimize radar visibility. At the last moment, it penetrated the building's outer shell. The warhead was a delayed fuse penetrator, designed to explode only after breaching the structure. The half-second delay allowed the missile to detonate inside the command room, amplifying the shockwave within enclosed volumes. Lights flickered across terminals, but the network backbone was destroyed. Servers, racks, and cabling collapsed in silence. For the operators inside, the screens glowed but carried no data. In military terms, this condition is worse than a total blackout. It induces hesitation, forcing decision-makers to misinterpret phantom signals. Almost simultaneously, Flamingo 2 followed a slightly different trajectory into the same complex. Its strike targeted the field communications cabin and the power distribution node. Once again, the delayed fuse warhead bypassed the outer layers, destroying the system from within. This second strike deepened the paralysis. Even if emergency power could be restored, the damage to fiber backbones and distribution hubs meant repair cycles would take weeks, not days. At one point, GNSS interference was observed approximately 15 kilometers from the terminal, but the missile shifted seamlessly into autonomous mode. By the time signals re-established, the error margin had already been corrected. Russian Pantsir batteries attempted interception during this phase, but low-altitude geometry and urban reflections prevented effective lock-on. The FSB complex appeared outwardly intact after the twin strikes. Walls still stood, administrative offices remained untouched, yet the essence of its function, command, coordination, and secure communication, was annihilated. For frontline Russian units dependent on this hub, the sudden silence severed operational coherence. Orders could no longer be distributed, intelligence flows were cut, and local field bridges collapsed. While chaos spread inland, Flamingo 3 approached its maritime objective. The target was a small pier in Sevastopol harbor, where patrol hovercraft were moored and supported by fuel supply manifolds. The missile stabilized at an altitude of just 15 to 20 meters, hugging the sea surface on its terminal approach. The strike was programmed to detonate internally, focusing destructive energy inside critical nodes. Upon impact, the fuel line ruptured, and the small command cabin at the pier disintegrated instantly. The mooring piles collapsed into the water. At least one hovercraft-class patrol vessel, identified as an A8 or A25 PS, capable of transporting 8 to 25 Marines, suffered severe structural damage after losing mooring integrity. Other vessels were stranded without refueling capability. The pier itself was rendered inoperable, with both the fuel cycle and docking capacity cut off. Russian defensive fire continued, but by this stage, there were no additional missiles to engage. The Ukrainian strike package had concluded within a carefully calculated window, exploiting seconds of confusion to deliver maximum structural and functional damage. For Russia's Black Sea Fleet, the effect was immediate: a compromised pier, disabled patrol craft, and an unsafe harbor entrance. For Russian intelligence and command structures inland, the loss of Armyansk's FSB hub created silence where constant flow of directives once existed. The climax of the attack was not measured in collapsed buildings but in operational paralysis. Flamingo 1 and 2 had reduced the FSB complex from a fortified node into a hollow structure. Flamingo 3 had turned a functioning pier into an unusable block of concrete. The value of these strikes lay not in physical destruction alone, but in the disruption of networks, energy distribution, communications, fuel supply that sustained Russian operations in Crimea. When the echoes of the final detonation subsided, the scope of the operation became clear. In the span of less than an hour, Ukraine had delivered simultaneous blows across multiple domains: land-based command centers, coastal radar coverage, and naval infrastructure. The 3 Flamingo missiles, synchronized with the UJ-26 drone wave, had achieved effects far greater than their limited numbers suggested. The immediate outcome was measurable. The FSB border base at Armyansk, though physically standing, no longer possessed any command and control capability. Its internal power distribution was cut, its communications cabin destroyed, and its data backbone silenced. Russian units that relied on the hub for coordination faced sudden isolation. Repair work would not be a matter of days but weeks, given the depth of damage inside critical distribution nodes. In Sevastopol, the small pier targeted by Flamingo 3 was effectively eliminated as an operational facility. The ruptured fuel manifold and collapsed mooring piles severed docking capacity. At least one hovercraft patrol boat was disabled, while others were deprived of fuel and logistical support. The harbor entrance itself was deemed unsafe for routine operations. Russian defenses had not failed for lack of capability. The S-400 system, designed to intercept cruise missiles at extended ranges, remained lethal on paper, but the geometry of the engagement dictated otherwise. Flamingos flying at altitudes of only 20 to 30 meters remained beneath the radar horizon until they were within 20 to 25 kilometers of the target. By the time detection occurred, missiles were already overhead. Frontal intercepts were nearly impossible within this compressed window, forcing defenders into rear chase scenarios. Particle clouds from interceptor warheads dispersed harmlessly behind the missiles. Coastal clutter and Doppler filtering further complicated locks, producing false tracks and broken solutions. The result was not weakness in the S-400, but a tactical defeat produced by terrain, timing, and low-altitude discipline. The drones had played their role with precision. Their strikes on radar power systems and waveguides had not blinded the network entirely, but delayed its reaction by critical seconds. That small temporal distortion gave the Flamingos their opening. It was dilution, not destruction, a spread of noise and delay across the defense grid that prevented focus on any single target. 2 drones had been intercepted by Pantsir batteries, but 4 succeeded, enough to bend the radar picture at exactly the right moment. Technically, the Flamingos validated their design philosophy. Each carried warheads exceeding twice the explosive mass of a Tomahawk, configured with delayed fuses for underground and internal detonations. Their redundant guidance package neutralized jamming, shifting seamlessly between GNSS, inertial, and terrain reference systems. Their fiberglass composite frames resisted electronic interference, and their long range allowed flexible vectors of approach, creating uncertainty for Russian planners even when the actual targets lay nearby. The missiles were not optimized for speed. Instead, they exploited geometry, endurance, and timing to defeat a layered defense that on paper should have been impregnable. Strategically, the operation carried asymmetric weight. 3 Flamingo missiles and a handful of drones had forced one of the world's most advanced air defense networks into temporary paralysis. The damage inflicted, loss of a command node, disruption of naval infrastructure, and functional blindness was disproportionate to the cost of the weapons expended. It demonstrated that even heavily fortified zones like Crimea could be penetrated when attack vectors were combined and synchronized with millisecond timing. The risks had been high. GNSS jamming could have shifted impact points by tens of meters, potentially wasting the strikes. Pantsir batteries had attempted interceptions, and the 96L6AP radar showed moments of instant recovery. Had operators maintained continuous lock for even a few more seconds, one Flamingo might have been destroyed. Yet every contingency had been accounted for: redundant guidance, multiple strike points per target, and time-on-target discipline. No single error chain materialized. All 3 Flamingos reached their objectives. The broader assessment was clear. Ukraine had proven that layered defenses could be forced open, not by overwhelming firepower but by orchestrated precision. A few seconds of delay, a few kilometers of radar shadow, and a few overlapping trajectories were enough to create exploitable gaps. The lesson for Russia was equally clear. To counter such attacks, redundant sensor nodes, alternative power and fiber backbones, and mobile low-altitude capture antennas must be deployed. Until then, the gaps revealed on this August morning would remain. In the end, the attack was more than a tactical victory. It was a demonstration of how asymmetric warfare, leveraging cost-effective systems against far more expensive defenses, reshapes the battlefield. 3 Flamingos and several drones altered the operational calendar in Crimea, leaving Russian planners to rebuild confidence in a shield that had been pierced. The message was unmistakable. Even the most advanced defenses are vulnerable when confronted with ingenuity, timing, and precision. Thank you for watching.